Hello, hello. This video covers how to provision an RDS Aurora Postgres database with the BoltOps Pro CloudFormation blueprint. This blueprint is extremely configurable and flexible. You can configure them with things with parameters as well as variables. And when we go and kind of demonstrate this, you'll see how configurable it is and everything. The default database is Aurora MySQL, and we're going to do Postgres in this video, so we're going to change some of these defaults, okay? Storage is encrypted by default, and there's this whole manage DB subnet group business. You could provide the template with subnet IDs, in which case the template will create you a manage DB subnet group, or you can use the existing DB subnet group name, which we're going to use here. You could also control the number of databases you want with the DB count variable. So if you use one, it's just to provision one master database. If you use two, it's going to be one master and one slave. If you use three, it's going to be two replicas and one master, okay? And then you can also configure and tune auto-scaling and use different predefined custom metrics or predefined metric types there to scale up and down your Aurora cluster. Additionally, you can create an optional Route 53 record that connects to the dynamically created DNS record that RDS provisions for the cluster reader and writer endpoint. And for this, I recommend internal IP addresses or internal Route 53 records, of course. Okay, so you can see there's a lot of things going on with this blueprint and template. There's a lot of things to configure all that. We're just going to configure kind of the bare baseline here to get you started. That gets you pretty much over that first initial gate. And actually that's how I recommend approaching this too with databases, because it takes a decent amount of time to provision a database, up to 15 minutes here usually. So I would say just configure the bare minimum, get it working. That way, if you make a mistake with one of these configurations and it rolls back, you don't roll back to a blank slate. You roll back to at least the database, and then you can add these other features there. And that's how I would kind of approach it. That's will save you some time. To use this, it's pretty simple. You just add the blueprint to your gem file, you configure some values, and then you deploy the blueprint. So we're going to do all those three steps. I did want to point out this table right here, compatible parameter values and variables. So each specific database requires specific database settings. So if you use, even like within the database, if you use like a specific version, only a specific version, a database parameter group family will work. So this table summarizes some tested values that will work. If you use incompatible values, the stack will roll back. So this will save you a bunch of time if you study this kind of beforehand, okay? And use the values kind of provided here. Or you could actually, here's another doc right here. I put together a doc showing off some CLI commands that you could use to get more information about the database engine, the DB parameter group family values that you could possibly use, and the parameter values here that you could use itself, okay? So that should get you pretty far. This is some more information about how you configure auto-scaling here, using custom VPCs, just suggesting you should use the private data subnets that's provisioning as part of the reference architecture. If you're not using the reference architecture from BoltOps and you have an existing VPC, then you could use that too. This is completely configurable, and you could use whatever you need. Talks about security groups there. There's a Route 53 record. And then last consideration before we kind of start the demo here is usually the general recommendation for me is usually don't provision stateful resources with CloudFormation. I mean, I do, but generally I use it for stateless resources. And the reason is CloudFormation, depending on what property you update for the resource, can actually entirely replace the resource. And for databases, that means it will replace the database and you lose your data. So that's pretty dangerous. However, you could easily kind of go around this with this guardrail right here. Just set your database configure a DB cluster identifier. If you set that, then if CloudFormation tries to provision a new replacement resource, it's going to collide with the existing database cluster identifier. And then it's just going to roll back immediately. And you kind of want that behavior there, okay? So that's a pretty good guardrail, and that's kind of like quickest way to actually force the rollback. There are some other things you configure, but then the rollback happens later. So this is one way, one strategy to kind of provide that guardrail there, okay? Okay, with that being all said, I know that was a decent amount of kind of review for this README because it's actually a pretty complex and big blueprint here. So we are going to get started now. First thing we do is open the gem file and add the blueprint. So I'm going to add the blueprint here. And you notice up here, I have a kind of helper method, at least in this project, that just wraps that gem call. So that's the same thing. I'm just use the prettier form, okay? Once you have that, you just run bundle to make sure the blueprint's available. You can also run lono blueprints to verify that the blueprint is being used, okay? And now once that's done, we can run the C commands to create the starter config. So I'm going to run both of these C commands right here. That's for development. And lono env production, lono seed aurora is for production. Now let's inspect the configuration values. Let's start off with development. And then we'll just also open up the variables. So let's actually focus on the parameters first, and then we'll work on variables. Okay. So we'll go here and kind of sort this. Move it to the top. So that's what we need to set. That's okay. So DB subnet group. Notice this comment. Must set either DB subnet group or subnet IDs. So if you have existing DB subnet group, you could just use that, and then the template will not use these subnet IDs down here. And that's what we're going to do. Because the reference architecture and VPC output right here actually has the private DB subnet group already. And what DB subnet groups do is it just tells RDS where to provision, which subnets to provision the RDS database system to. Okay, so we're going to use that. We're good. We have to change this to Postgres now. So I'm going to go grab those Postgres values from this table. Aurora Postgres. Let's try again. Okay, so that's the engine. Now we need the engine version. And remember, these values have to be compatible, okay? Here's the compatible version number. The username, password, that doesn't matter. Well, other values need to be compatible. The DB parameter group. So let's go find that one right here. So that needs to be compatible too. And then lastly, look, so Aurora Postgres, at least currently, it doesn't support a DBT3 small. It supports a DBT3 medium. So we have to make sure you have to use that instance type, or else the stack will roll back. So that's covered. And then lastly, is the variable actually. So parameter groups, parameter values in the parameter group are actually controlled by variables. We'll open up and you can see it right here. This is for Aurora and this is for Postgres. So make sure you use the Postgres value, okay? So I think that looks all good for development. Let's go ahead and set production also, and we'll just do launch the stacks at the same time. So again, I'm going to sort these guys together. Put them at the top. Now I got to switch over to the production account. I'm using a multiple account strategy here. Grab the private data DB subnet group. And this is production. Now I change the engine, so I'm going to actually just grab it from here to make it quicker. So grab this, paste that over, grab it from here, paste that over. So I'm setting the engine version, and the DB parameter group family. And again, almost missed it, the DB class, or else that's going to roll back, okay? These subnet IDs here, we're not going to use that because we're going to use the DB subnet group. And the reason why I make this required here is because it's pretty easy to forget. Let's say you are configuring your VPCs. Oh, I found something I forgot. But let's say you're configuring VPCs here, and you want to use a managed DB subnet group. It's pretty easy to forget to set that subnet IDs and then have them mismatch where that subnet DB group is provisioning the default VPC, which you don't want maybe, and then you have a custom VPC down here, then the stack rolls back. So that kind of ensures that you set it properly, or that at least guides you the right way. So here's the production VPC value, and let's go ahead and grab the development one too. I'm glad I caught that. Switching development account, grabbing the outputs for VPC. here. Now I'm just going to kind of review all this. So this looks like everything's set that we needed. And look, also, I should have pointed out, look how configurable this blueprint or template is. And you can see what the lonoc command did. It generated this, and then it kind of grouped all the parameters pertaining to the specific resource together. Generally, the blueprints are written that way. See, you can see that's all the subnets pertain to the DB subnet group. Here are parameters related to the DB instance. Here's a parameter related to security group. Here are parameters related to autoscaling policies here. Here are parameters related to the Route 53 record for the pretty endpoint. Okay, so it's all configurable. But again, I recommend just setting kind of the baseline just to get things up and running first, and then going and playing and adding more to it. That way the databases are being provisioned. And if you do make a mistake and it rolls back, you still make, you don't end up with the starting from scratch. So that looks good. On this side, that looks good too. I know I'm gonna have to fix this production RB, so let's do that. Okay, this production RB needs to use this value because the parameters are specific to the database engine, and that parameter time zone is not going to work for Postgres. This one will. I just use the default value I found off by looking at the parameters and just using any default value. You need at least one value in order to create a DB parameter group for the cluster. So that's why this is required. Okay, so that looks pretty good to me now. Let's go ahead and grab the deploy commands and let's kick off this deploy. I'm going to deploy the first one with no wait and the second one with the wait, okay? So grab this. Let's kind of move this all together now. Okay, and now we just run the first deploy command. So the first deploy command deploys to the development account and the development environment and deploys the Aurora there. And the second one, I'm doing the production, Lono env production, Lono CFN deploy Aurora, sure. But I'm not using the no wait option because I want to see the output here. Okay, the no wait option just basically fires it asynchronously, and then you don't have to wait, and it doesn't pull for the status updates. You can always check for status updates in here. So here I'm going looking at Aurora right now. You can see in development, it's starting to create all the resources necessary, okay, to make this database happen. And then in production, we'll just kind of verify that create in progress is happening. Right here, create in progress is also happening here. Now again, databases take a while to provision with RDS. It takes about 15 minutes or so. So I'm going to go ahead and pause here so y'all don't have to wait. Okay, so that finished completing. Here is the development account with the Aurora database now. This is Postgres. We can click on, I guess, events here to see how long it took. It started at 13:41 and it finished at 13:55, so about 15 minutes. Well, let's double check production. Click on events. Let's click on Aurora events, and down here it started at 13:41 and it finished at 13:55. You can also see, since I did not use the no wait option here, how long the stack deployment kind of took. Okay, let's actually look at the resource. Let's go look to RDS database instance right here. We click on that. That will open it up. And you can see the RDS database on here. This is production. There's the cluster, and then there's actually the writer. Okay, and then let's check dev too. Dev also has the database. Okay, and like I said, I didn't specify the database cluster instance identifier, but I actually recommend that if you are using this like on production. You don't want to accidentally delete the database by changing the property. You want the force that rollback, but in this case, I just did it for demonstration here. And that pretty much covers it. So again, we do kind of 3 steps. You configure, you deploy, and you run, okay? And we use this blueprint to provision RDS Aurora database in Postgres this time. And probably the most important thing I want to emphasize is this compatibility table here. Make sure that you review this to make sure that the process goes smooth. But essentially, that is it. That covers the Aurora RDS database CloudFormation blueprint here with Postgres. Okay, hopefully you enjoyed that, and hopefully that was helpful. Cheers.